Okay, we're going to continue our study of descriptive statistics by moving to a discussion of this area, measures of spread outness. So you can tell from our big picture that we're going to talk about range, sum of squares, variance, and standard deviation. All right, so let's get started. I'm going to pull up the PowerPoint called Measures of Variability. So just to review, if you remember last time we talked about the mode, the median, and the mean, and we talked about how both of these can create some problems when we're trying to find the one number that best represents the distribution. The mode only looked at the most frequently occurring score. The median looked at that middle score, and the mean, of course, looked at the average, or it's that balance point of the distribution. Okay, but I want to show you an example here with the pen. Click on the pen there. All right, and I want to take a look at a couple of just small distributions here. So pretend like that line is straight if you don't mind. So if I'm looking at a distribution that looks like this, and the mean is equal to 80, and then I have another distribution down here like this where the mean is also equal to 80. But I want you to consider if under here these represent people's scores, right? So if I was going to plot all the scores, all of these, actually I'll just do little dots and see if that would work. But these are all scores, all scores, all scores, all scores, even some out in the tails. So these are all people. And when we looked at it together, it was a mean of 80. And the same thing up here, except now the scores are more bunched together. So imagine a situation where you're given a piece of information and that information is the mean. So this group of people has a mean of 80 and this group of people has a mean of 80. But consider what the ability in those two groups looks like. Okay, so here everybody is scoring right around that mean. So the mean somewhere right about here, and all the scores are pretty close. So maybe they range from, who knows, like 75 or 76 over here to about 84, 85 over here, but they're all pretty similar compared to this group where your mean is still 80, but now you have people up here, you know, maybe around 100, 110, and down here around 50 or 60, and then you have a spread all around here. So when we're thinking about group composition, and if this is some measure of ability, these people are more similar than these people down here. Okay, does that make sense? So that if we're only looking at the mean, we might, incorrectly in this case, be led to believe that these two groups are similar in their ability. But we can see that this group's ability is much more spread out, still has a mean of 80. This group's ability is much more similar, again, a mean of 80. So the second point here, central tendency is often not enough. It does not tell the entire story of the data, right? So that's what I'm talking about here, in that we need more information. Just looking at central tendency is not going to be enough in some cases. So just like there was a problem with the mode and the median and the mean and the mode and the median, now we're seeing, okay, the mean does a pretty good job, but it really doesn't tell the whole story of what's going on with our data. So you know it, they have something else for you, and those are going to be our measures of variability, or I call them measures of spread outness because that's really a little more descriptive as far as what we're actually looking at. Again, when the means are equal, thinking about this second point here, when the means are equal, the distributions could look quite different. All right, so let's look at another example here. What if we had a couple of different teaching styles? So I'm just going to say TS. and we have teaching style, oops, supposed to be an A, and then we have teaching style B. All right. And we give the students in this class a pre-test, and then we give them a post-test. Forgive that writing. All right. I guess that's a good way of making sure you're paying attention, because if you are not, you're probably not going to be able to tell what my writing says. Okay. So thinking about the pretest, in the beginning, these people had a scored a 1, 2, 3, 4, 5. So say you have 5 people in group A. So my box is going to be too small. I'll tell you what, let me just erase this real quick. Doesn't take long. Let me start a little bit bigger. Sorry about that. This is the bad part of using this pad over here. Okay, so if I am looking at a couple of different teaching styles, and I'm looking at pre-test versus post-test. So again, this is pre and this is post. And at first, the scores are 1, 2, 3, 4, 5. And that would have a mean of what? What would be the balance point there? 3. And in style B, the scores also were 1, 2, 3, 4, 5. All right, so our groups, you can tell, are starting out equally. They are equal. So this is style A and this is style B. So we run our intervention and then we take a post-test. All right, so in the post-test, our scores go to 0, 0, 3, 6, 6. All right, so what would our mean for the post-test for group A be? Again, we're looking at the balance point, right? So that would be a 3. And in this style B, our scores went to, in the post-test, 3, 3, 3, 3, 3, for a mean of, you guessed it, 3. Okay, so now we can see that if we are some sort of program evaluator or a person looking at these two teaching styles, we might be led to believe, just looking at the means, that style A did not differ from style B, right? Because our means were at 3 and then they stayed 3. Again, we started at 3 here in B and then we went to 3 here in the post-test. So no change, no change. But as point 2 says, when the means are equal, the distributions could look quite different. And so they do look different. We can look at the distributions and see that even though our group started the same, the way they ended up, these people went down to 0, this person remained the same, and these people went up to 6. Everybody kind of bunched in the middle here in style B. So we definitely have distributions that look quite different. So if we were only looking at the means, we might come to the wrong conclusion as far as the quality or the effectiveness of these two teaching styles. All right, so we need some more information. One of those solutions is the range, and the range is simply the difference between the largest and the smallest score. And it's just, if I'm looking at, oops, sorry, let me mark on my pen again. If I'm looking at those scores from style A, 1, 2, 3, 4, 5, it's simply 5 minus 1, which is 4. You got it. So that's the range. Super easy to compute. Let's see if I did the other style B, 6, 6, and this is style B from the example before. I'm going to have 6 minus 0, and so 6 is my range, right? Okay, not hard at all. It gives us a real kind of brief look at the spread of the scores. So I want you to think about this next question. Can the range be negative? Can the range be negative? All right, so a couple things I want you to remember. You might want to pause it here and think about that first, because I'm going to go on. If the range is a measure of spread outness, right? What if I have a set of scores like this? So I have 3 threes. I have 3 threes. So my data set, my little small data set, is just 3, 3, 3. All right. So can the range be negative? So what would my range be on this one? 3 minus 3, right? The range would be 0. And we can see what that looks like plotted, because this says, hey, there's no spread outness. This, we can see that they're not spread at all. They're just stacked in a line. They're just stacked there. So can range be negative? Well, in this case, if I have 0 spread outness, can I ever have less than 0 spread outness, which would be a negative number, right? And the answer is no. I can't have more spread outness than no spread outness. Okay, can you see that? All right, let's look at this next slide. Some advantages to the range. Easy to compute, as you can see. Provides an initial check of the scores. You can check for data or input errors. So you can imagine that if you have a set of data that the scores go from 0 to 100 and you check the range, and the range is like 1250, then you know you probably have some input errors somewhere. Something wasn't inputted, because you should not have a range that large. The disadvantages are it only represents the 2 extreme scores, and it doesn't tell us anything about what's happening in the middle. Okay, so let's look at an example of that in A. But if you have the scores 1, 3, and 5, your range would be 5 minus 1, which equals 4. And then you have set B, which is 1, 3, 3, 3, and 5. So the range for that one is going to be 5 minus 1, which also equals 4. All right, but if we're looking at them, looking at our 2 distributions, 1, 3, and 5, 1, 3, and 5, 1, 3, 5, 1, 3, 5. All right, so set A, I have 1, 3, and 5. And then here I have 1, how many threes? 3 threes, 2, 3, and then 5, right? Okay, so if we're talking about the spread outness of the scores, if we only looked at the range, we're going to be led to believe that these 2 sets of scores are equally spread out, are equally variable. But this distribution is more spread out, or has more variability than this distribution. Okay, it's because of these 3 stacked in the middle, right? So what range doesn't do for us, it doesn't tell us what happens between the highest and the lowest scores. So this only talks about the highest and the lowest, highest and the lowest. They appear to be identical, when in reality, you can see they're definitely not identical. Okay, so what we need is another statistic, of course, to help us and give us some information about what's happening in the middle. Okay, I'm going to pause here.